Hey everybody. So we're getting into 9.3 today, finding the product of polynomials. We're going to be doing more multiplying in this lesson. All right. So if you felt good at 9.2, today is going to be a little bit more of the same, but slightly different. So go ahead and get the title here, get this first example, and we'll get going. Okay, so a big part of today is just the multiplication that we're going to be doing is going to be presented to us just slightly different than it was in the last lesson. If you guys take a look at this first example here, they're asking us to find the product. Remember, product just means multiplying. All right, and what we have here is a binomial being squared. Okay, so the question is how do we go about multiplying this? Okay, well the first thing I want to point out is you might be tempted to distribute the 2 into the parentheses, but we cannot do that because of this addition symbol. All right, we've done that in the past, but it was always when things were being multiplied together. For example, if we just had 3x to the power of 2, both of these would get a power of 2. But this plus sign means we cannot just distribute. Okay, so what we need to do is rewrite this thing. Okay, if we have 3x plus 4 squared, that means 3x plus 4 is being multiplied by itself, right? So another way of writing this would be 3x plus 4 times 3x plus 4. Okay, and this is really what's going on here. From here, it's the same stuff we were doing before, where we're just going to distribute and look for like terms, and then we'll kind of go from there. So let's go ahead and do that. We have 2 things we need to distribute into this parentheses. Let's do them one at a time. Let's start with the 3x. So I'm going to multiply the 3x by everything in here. So 3x times 3x is a 9x squared. 3x times 4 is a positive 12x. Okay, moving on to the next term that needs to be distributed, the 4. Okay, so 4 times 3x is a positive 12x. 4 times 4, 16. Okay, just be careful. You might be tempted to stop here, and sometimes you will if you have no like terms, but we do have like terms. We have a 12x and a 12x that we can combine together. So let's bring down the 9x squared. 12x and 12x gives me a positive 24x, and then this 16 comes down as well. Okay, and there it is. There's our answer. Okay, and just something I want to point out. What if you accidentally distributed the square in here? Would we get the same answer? Well, 3x squared would give us a 9x squared, and 4 squared would give us a 16. But that 24x, that wouldn't happen if we did it incorrectly. So that's why we can't just distribute the 2 into both terms. Okay, cool. So let's try another one here, just with some weirder values. We're gonna have multiple variables in this. It's really not going to change a whole lot. Okay, but let's try this one out. Okay, so again, find the product. This is technically called the square of a binomial. Like if you ever see that in like the directions, that's all they're talking about. Okay, so we're gonna do the same thing. So we got a 5x minus 2y being multiplied by itself, a 5x minus 2y. All right, so yeah, let's just go ahead and distribute on this, and let's see what we end up with. So distribute the 5x into the parentheses. 5x times 5x is a 25x squared. 5x times negative 2y. Okay, well, 5 times negative 2 is a negative 10, right? X times y, we can't actually multiply those together, so we're just going to put them side by side. When you multiply variables, different variables, put them in alphabetical order. So I'm going to write this as a negative 10xy. Okay, moving on to the next one, negative 2 times 5x. Negative 2 times 5 is another negative 10. Y times x gives me a yx, but I need to write it alphabetically, so xy. Okay, and then the last thing, negative 2y times negative 2y. Looks like I'm going to get a positive 4. Y times y squared. Okay, so it looks a little different, but it's really, not any more difficult. We still might notice we do have like terms, right? We have these xy's we can combine. So this 25x squared bring down, right? We cannot combine that x squared with the y squared, right? Those are not like terms. Okay, but we can combine the negative 10 and negative 10 to get a negative 20xy. And then this 4, positive 4y squared comes down. Okay, just something to remember. If we had more terms, I would probably be crossing things out as I brought them down. But since there's just 4 of them, sometimes I just don't do it because, I feel like I'm not going to miss anything. Okay, and there it is right there. Yeah, so I'm going to have you guys go ahead and try out one of these on your own. Go ahead and find the product of this square of a binomial, and then we'll move on to some other problems. Okay, so first thing is rewriting this, a 4x minus y times a 4x minus y. Okay, so from here, we can distribute the 4x into the parentheses. So 4x times 4x is a 16x squared. 4x times a negative y. Well, 4 times negative, that's technically a 1, right? Is going to give us a negative 4. X times y is xy. Okay, and distributing the negative y into the parentheses. Negative y times 4x is going to give me another negative 4 yx or xy. And then negative y times negative y is a positive y squared. Okay, something you've probably already started to notice. When we go to do the square of a binomial, these two terms in the center are always the same, right? Negative 4xy's. On this one, they were negative 10xy's. On the last one that we did, they were both positive 12x's. That's going to happen whenever you have a square of a binomial, just so you know. So it'll help you to not maybe make a mistake. All right, but yeah, like terms in the center, like we normally have on these. So I'm going to bring down that. Negative 4 and negative 4 gives me negative 8xy, and then y squared. There is our final answer. Okay, so that's the find the product. You know, there's some patterns that you can notice in there. But there's not really a little shortcut. I think some books might try to like make you think, oh, I can do a shortcut. I can square this and I can square this, and then I'm gonna, like figure out that these are negative 4s and the xy's. I don't know. Like it's not worth, I think, trying to figure out a little shortcut on these because they're just so simple. Okay, but maybe on the next problems we might find a shortcut. Let's see what happens. Okay, so on this next one, they're asking us to find the product, again, multiply. These ones are called a sum and difference pattern. All right, so go ahead and copy this and I'll show you what's going on. Okay, so basically when you see a sum and difference pattern, it's when we have two of the same terms, and the only difference is they're being added in one of our, I guess, binomials, and they're being subtracted in the other. Okay, so this is a sum and difference pattern, but it's the same thing as we always do. We're going to go ahead and just distribute and do all that stuff. So let's do it, and let's see maybe if we figure out what they mean by a pattern on this. All right. So 3x times 3x, and then 3x times a negative y. So 3x times 3x is a 9x squared. 3x times negative y is a negative 3xy. Okay, and then let's see what happens when we distribute the other one. Careful, this is not like the square of a binomial. This isn't necessarily going to give me the same stuff. Y times 3x gives me a positive 3xy. And y times negative y gives me a negative y squared. Okay, so just like before, we're getting like terms in here. Here's the thing. Negative 3xy and a positive 3xy, negative 3 plus 3 is 0. And in other words, these two terms, these like terms, they cancel each other out. They turn into a 0, which we don't need to write. So I'm going to bring down the 9x squared. These cancel each other out. They're gone. And we have this negative y squared. Okay, and that canceling out of the two terms on the inside for these sum and difference patterns is always going to happen. All right. So if you guys ever look at this, there you can potentially find a shortcut where you're just going to say, oh, 3x times 3x is a 9x squared, and y times negative y is a negative y squared. That's the kind of the pattern they want you to notice. Okay, but I still don't know if it's worth the hassle. Sorry, I forgot this area of memorizing this pattern for this really particular type of problem. So I'm not a fan of the memorization of the patterns. I say just do the distribution like you would any other problem. Combine like terms, get your answer. Okay, but if you feel like you recognize the pattern and you want to use them on these problems, go for it. Okay, so let's try one more of these, and then I think I'll have you guys try one on your own. So let's use the pattern on this. Let's do it. Here's what I know is going to happen. I'm going to do a 4a times 4a and get a 16a squared. And a negative 10b times negative or positive 10b is going to give me a negative 100b squared. Okay, and I know those middle terms that I would get if I did all of the distribution here, they would cancel each other out, and I would end up with this anyway. Okay, so that's my answer. But again, I don't love this because it, it's so easy to think that this sort of pattern is going to work on all of them, and you're always just going to multiply the first two terms and the second two terms, and then you're done. No, that only works for the sum and difference pattern because this is the same for 4a 10b 4a 10b. One of them subtracted, one of them's added. Okay, so if I were to do this problem, I would have actually done what we did on this one. Okay, but I just wanted to show you this is one of the ways you can use the little shortcut pattern if you like it. Okay, so on this practice problem, go ahead and look at this one. Notice it is a sum and difference pattern. So if you'd like to use the shortcut, go for it. If you'd like to do it the long way, do that as well. Go for it. Okay, so let's try this out. I'm going to do it the long way. So for those that did it the short way, you can see that you will get the same answer as long as you did that little shortcut correctly. So x times x is x squared. X times negative 3y is negative 3xy. 3y times x is a positive 3xy. And then 3y times negative 3y gives me a negative 9y squared. Okay, be careful with all of that stuff. It's really easy to like forget the squared on the end of the y or anything like that. Okay, these middle terms, negative 3x y and positive 3xy cancel each other out. So I'm just left with this x squared minus 9y squared. And there it is. Okay, cool. So that's a little, I guess, refresher on multiplication. Really simple lesson. Maybe could have been combined into the other one, but I felt like it was worth doing it separately. So yeah, that's that, guys. Pretty good, pretty easy one. I'll see you in class. Bye.